Hello students, let us continue the session on pair of linear equation in two variables. In our previous session, we started with the revision of this chapter. We had discussed few questions. We had stopped at short answer type question 2. In that, we had solved one question. I had given you this question. I have shown you how to check whether the given set of equations are consistent or inconsistent. If they are consistent, obtain solution graphically. I had left two sub-questions of this main question. Hope you must have done that. Let us continue further part of revision. I'll take up the next question. Go through the question. Half the perimeter of a rectangular garden whose length is 4 meters more than its width is 36 meters. Find the dimensions of garden. Let me consider the length of the garden as x meter and width as y meter. Let length be x meter and width be y meter. Perimeter of rectangular garden is given by 2 times of length plus breadth. So perimeter will be two times of length plus width is x plus y. Since they have given half perimeter is given as 36 meter. So if you consider the perimeter to be p, x plus y will be p by 2. Half the perimeter of rectangular garden whose length is 4 meter more than its width is 36. So half the perimeter is 36. Therefore, we have x plus y equal to 36. This is equation 1. Also, they are given length x is 4 more than width, 4 meter more than width. So I can rewrite this equation as x minus y equal to 4. This is my equation 2. Now I have to solve these two equations to find the value of x and y. Since the previous question was related to graph, I would like to solve by graphical method. For that, I have to consider both the equations and I have to find out the x and y coordinates. Let me consider the first equation. First equation is x plus y equal to 36. So I can take x transposed that side. We get y is equal to 36 minus x. Let me find different values of x and y. When x value is say 20, the value of y becomes 16. If x value is taken 24, the value of y becomes 12. Let me take up one more equation. second equation. For the second equation, x minus y is equal to 4. I can write y as x minus 4. So when the value of x is taken as 10, the value of y will be 6. When the value of x is taken as 20, the value of y will be 16. Now you could have guessed what is the answer. You have guessed probably this 20, 16 is the answer. Let me plot the graph and confirm whether the solution is 20, 16. On plotting the graph, we get two lines. The line x plus y is equal to 36 and x minus y is equal to 4 intersects at 20, 16. Therefore, I can conclude that x value is 20 and y value is 16. X is nothing but the length of the garden and y is nothing but the width of the garden. Let's continue with the third question. Question 3. Given the linear equation 2x plus 3y minus 8 equal to 0, write another linear equation in two variables such that the geometrical representation of pair so formed is first one intersecting lines, second one parallel lines, and the third one coincident lines. What is given to us? Given is one of the linear equation. Linear equation is two x plus 3y minus 8 equal to 0. This is equation 1. Now I have to find equation 2 for these three conditions. First condition is intersecting lines. For intersecting lines, I know the condition. The condition is a1 upon a2 not equal to b1 upon b2. So I have to take some value for coefficient of x and y such that a1 upon a2 is not equal to b1 upon b2. So one of the possible equation may be taken as, this time I'll consider say 5x plus some 2y minus 9 equal to 0. Now you can see a1 upon a2 is 2 by 5. b1 upon b2 is 3 by 2. They are not equal. So this could be the second equation. Let me move further for parallel lines. For parallel lines, the condition is a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2. So I have to make the second equation such that the ratio a1 upon a2 becomes equal to b1 upon b2, and the ratio of the constants should not be equal to the previous one. So possible equation may be, this time I'll take 6x plus 9y, some other equation, plus 7 equal to 0. Look at the ratio. 2 upon 6 is 1 upon 3. 3 upon 9 is 1 upon 3. A1 by A2 is equal to B1 by B2. C1 by C2 is minus 8 upon 7. So it holds true for parallel lines. So this may be the second equation. You must notice each time I am writing here maybe, because you can consider some other equation also. Let me take the third one, coincident lines. For coincident lines, the condition is A1 upon A2 equal to B1 upon B2, which is equal to C1 upon C2. So possible equation may be, this time I have to take the coefficient and a constant such that all the three ratios must be equal. Suppose if I take 4x plus 6y minus 16 equal to 0, look at the ratio of A1 upon A2. It's 1 by 2. B1 upon B2 is 1 by 2. C1 upon C2 is also 1 by 2. So this may be the equation for second line. Next question is related to graph. Solve the pair of linear equations graphically. 4x minus y equal to 4, 3x plus 2y equal to 14. These questions which are related to graph, you should plot it on graph. Here I'll be solving them and I'll be telling x and y coordinates. You can solve it on graph book and check whether the answer matches with the answer which I give here. Suppose if I consider the first equation for 4x minus y equal to 4, I can write y as a minus y transpose this side, 4 transpose this side, I'll be getting 4x minus 4. So x and y values, I'll find it out. This time I'll take x value as 0, value of y is minus 4. If I take x value as 1, the value of y is 0. If I take 2, 8 minus 4 is positive 4. And the second equation for 3x plus 2y equal to 14, I can write y as 14 minus 3x upon 2. Always you should choose the value of x such that the value of y obtained is some integer. It becomes easy for plotting the graph. If I take it as 0, 14 upon 2 is 7. If I take this as 2, x value as 2, 14 minus 6 upon 2 is 8 by 2, which is 4. If I take the value of x as 4, the value of y is 1. With this set of coordinates, I have to plot the graph. Let me show you how the graph looks like. On plotting the graph, we will be getting two lines, 3x plus 2y equal to 14 and 4x minus y equal to 4, intersecting at 2, 4. The graph of given equations intersects at 2, 4. Therefore, the value of x is 2 and the value of y is 4. Question number 5. Determine the values of m and n so that the following system of linear equations have infinite number of solutions. This was asked in 2013 board examination, set 66. So one of the important question. Here they have given the equations 2m minus 1 time of x plus 3y minus 5 equal to 0 and 3x plus n minus 1 times of y minus 2 equal to 0. And they have mentioned that infinite number of solutions exist for these linear equations. So for infinite solutions, we know the condition that a1 upon a2 equal to b1 upon b2, which is equal to c1 upon c2. Remember, infinite solution will be there when the lines coincide. So I have to consider the condition for coincident lines. Let me substitute the values of a1, a2, b1, b2, c1, c2. I'll be getting 2m minus 1 divided by 3 equal to 3 divided by n minus 1, which is equal to 5 upon 2. Let me consider two m minus 1 upon 3 equal to 5 by 2. This implies 4m minus 2 equal to 15. This implies m value is 17 upon 4. If I consider 3 by n minus 1 equal to 5 by 2, upon cross multiplication, this becomes 5n minus 5 equal to 6. This implies n value is 11 upon 5. So m value and n value are found. Question number 6. Find the values of alpha and beta. This is alpha and this is beta, for which the following pair of linear equations has infinite number of solutions. The two equations are given. This question is also one of the important question. It was asked in 2011 board examination, set 25. So once again I have to consider like previous question for infinite solutions. Condition is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2. Now substitute the respective values. We'll be getting 2 divided by 2 times alpha, which is equal to 3 divided by alpha plus beta, which is equal to 7 upon 28. Consider 2 divided by 2 times alpha equal to 7 upon 28. If you cross multiply, we will be getting 14 alpha equal to 2 times 28, and the value of alpha will be 2 times 28 upon 14. We get it as 4. Now if you consider 3 divided by alpha plus beta equal to 7 upon 28. If you cross multiply, we get 7 times of alpha plus beta equal to 28 times of 3. I am not multiplying. The reason is this 28 is a multiple of 7. So alpha plus beta will be, upon cancelling, 28 is 4 times, we get it as 12. Now the value of beta is 12 minus alpha. Alpha value we have found it as 4. Therefore, beta value is 8. So alpha is equal to 4 and beta is equal to 5 are the values of alpha and beta. Question number 7. Represent the following pair of linear equations graphically and hence comment on the condition of consistency of this pair. The two equations are x minus 5y equal to 6 and 2x minus y is equal to 12. This is also an important question asked in board examination. We have to solve it graphically. So I have to consider both the equations, find the coordinates and then plot the graph. Suppose if I consider the first equation for x minus 5y equal to 6. If you transpose this 5y to the right hand side and 6 to the left hand side, I'll be getting 5y equal to x minus 6. So y is x minus 6 upon 5. Now let us consider some values of x and find the value of y. I have mentioned preferably you have to take the value of x as some number such that the value of y becomes some integer. Suppose if I take x value as 6, 6 minus 6 is 0 upon 5 is 0. If x value is taken as 1, I'll be getting 1 minus 6 which is minus 5 upon 5 minus 1. If I take the value of x as negative 4, the value of y becomes minus 10 by 5 which is minus 2. Now let me consider the second equation, 2x minus 10y equal to 12. So 10y becomes 2x minus 12. So y will be 2x minus 12 divided by 10. Here you can take 2 as common. So the equation changes to x minus 6 upon 5. Look at both the equations. This is from equation 1 and this is from equation 2. The values are same. If you find the value of x and y, it should be same. For x is equal to 6, value of y is 0. For x is equal to 1, the value of y is negative 1. For x is equal to negative 4, the value of y is negative 2. Now you must guess what could be the graph. Graph of these two equations will be overlapping. The lines will coincide. I'll show you how the graph looks like. This will be the graph of both the equation 2x minus y is equal to 12 and x minus y is equal to 6. They coincide. Let me mention it here. Graph of the given equations coincide. If they coincide, then there will be infinite solutions exist. If the solutions are present, we say that the system is consistent. Therefore, the system is consistent. When I mention system, it is system of the linear equations. Therefore, the linear equations are consistent. Let us solve one more question before winding up this session. Question number 8. For what value of p will the following system of equations have no solution? You must know that no solution will be there when the given lines are parallel to each other. This question is also one of the important questions. It is asked in the board examination. We know the condition for having no solution. Let me mention for no solution. The condition is a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2. Now let me substitute 2p minus 1 divided by the value of x is 3, because the second equation you have to rewrite this as 3x plus y minus 1 equal to 0, equal to p minus 1 divided by 1, which is not equal to 2p plus 1 divided by 1, because this equation you can transpose this one to the other side so that the same format is made. So it becomes 2p plus 1 divided by 1. Now I'll consider the first two. From 2p minus 1 divided by 3 equal to p minus 1 divided by 1, we'll be having, as multiplied, becomes 2p minus 1 equal to 3p minus 3. If you transpose the value of which is there in the right hand side minus 3 to the left hand side, it becomes 3 minus 1. If 2p is transposed to right hand side, it becomes 3p minus 2p. We'll be getting the value of p as positive 2. Now I'll consider from p minus 1 divided by 1 not equal to 2p plus 1 divided by 1. Now if you cross multiply, you will be getting p minus 1 not equal to 2p plus 1. Now if you transpose, we will be getting p as not equal to negative 2. Now if I consider one more possibility, from 2p minus 1 divided by 3 not equal to 2p plus 1 divided by 1, we have, this is 1, this implies cross multiply 2p minus 1 not equal to 6p plus 3. Upon transposing 2p to the right hand side, it becomes 4p. Positive 3 to the left hand side, it becomes negative 4. So p should not be equal to minus 1. Now I can consider, therefore, system has no solution when p equal to 2. Let us wind up this session. Furthermore questions are solved in the next session.